Have you ever felt like time flies when you are having fun or drags on during a long wait? While our subjective experience of time is certainly flexible, there is a fundamental scientific truth that might surprise you. It makes you wonder, does the act of moving itself truly affect the passage of time? The answer is a resounding yes. Moving fast really does slow down time, but not in a way that you would typically notice in your daily life. This incredible phenomenon is known as time dilation, a cornerstone of Albert Einstein's theory of special relativity. The core reason for this effect lies in the astonishing fact that the speed of light in a vacuum is constant for all observers, no matter how fast they are moving. Imagine a simple clock that measures time by a pulse of light bouncing between two mirrors. If this light clock is moving past you, the light pulse has to travel a longer diagonal path between the mirrors from your perspective. However, since the speed of light cannot change, the only way for the light to cover that longer distance at the same constant speed is for the clock itself to appear to tick slower for you. This means that time literally slows down for the moving object relative to a stationary observer. This is not just a theoretical concept. It has crucial practical applications. For instance, the Global Positioning System, or GPS, relies on satellites orbiting Earth at high speeds. Their onboard atomic clocks, which are incredibly precise, actually tick slightly slower due to their velocity compared to identical clocks on Earth. Without constant adjustments made to account for this time dilation, GPS navigation systems would accumulate errors of many miles every single day, making them completely useless. This mind-bending effect also leads to intriguing thought experiments, such as the famous twin paradox. If one twin embarks on a high-speed space journey while the other remains on Earth, the traveling twin would return to find their Earthbound sibling significantly older. Similarly, scientists observe this effect in particle accelerators where unstable particles, moving at nearly the speed of light, live much longer than they would if they were at rest, providing direct evidence for time dilation. Ultimately, time is not an absolute, unchanging constant but rather a flexible dimension intertwined with space, energy, and momentum. While we do not perceive these subtle shifts at our everyday speeds, understanding time dilation is fundamental to modern physics and essential for technologies that shape our world, reminding us that the universe is far more dynamic than it often appears.